non-destructive testing also. Different type of testing methods in that penetrant testing, magnetic particle testing, radiographic testing, eddy current testing, infrared testing, neutron radio, MFL, magnetic flux testing. Okay, so rebound test, vibrational analysis, leak test. So different types of testing methods are there. But whatever the testing method you can follow, no problem. But material should not damage. That is the condition in NVT. So in all the list, ultrasonic testing is one of the method. Ultrasonic testing. Okay, so whatever the source you can take us. For example, MPT, if you take, we will use magnetic field by sending magnetic field through the materials. We will test in MPT. Radiographic testing, by using radiation, we will test the material. In ultrasonic testing, by using ultrasonic sound, we are going to test. So somewhere radiation, somewhere magnetic field, somewhere liquids like penetrating, somewhere ultrasonic sound, different. So whatever the sources we are using for testing purpose, those are not going to damage the material. So that we are going to use in ultrasonic testing. So we are going to use in our NDT. So in all the list, our today's topic is UT, ultrasonic testing. American Society of Mechanical Engineering, section number 5, non-destructive testing. Article number 4 and article number 5. 4 for weldings, 5 for materials. Weldings and materials. Okay, so let me take you to my PDF, guys. Please respond. Hope you can see my screen. Everyone, hope you can see my screen. Please
Yes, sir.
respond. Thank you. So, American Society of Mechanical Engineering, section number 5, MDT, article number 4 for weldings, 5 for non-weldings. So, source in ultrasonic testing is ultrasonic sound. So, first of all, sound. What is sound? If someone asks you a question, what is sound? Sound is a mechanical vibration. Presently, I am in a room, the room having a fan. The fan is in rotation. The fan is in rotation. So I'm getting some sound from the fan. But if I switch off the fan, then I cannot get any sound from it. Only when the fan is in motion, sound will come. Where there is no motion, there is no vibration, there is no sound. So if you want to generate sound, compulsory there will be vibration in the medium required. Even right now, I am moving my hands, also will generate sound. I am moving my head, also will generate sound. Every movement which I will give will generate sound. Of course, depends upon our audible range, we are unable to hear. But we are unable to hear, that doesn't mean there is no sound. There is a sound, you are unable to hear it. That is the point. So simply what I want to say, sound is a mechanical vibration. First point. Second one, types of sound. This sound divided mainly into 3 types. Infrasonic sounds, sonic sounds, ultrasonic sounds. Infrasonic, sonic, ultrasonic. Infrasonic sounds means the sound which is having frequency less than 20 hertz. Less than 20 hertz. Very low frequency sound waves. Not audible. Okay, not audible sounds for the human. But not audible for the humans. not for all the creatures. Infrasonic sounds, some animals can hear these sounds. They can get these infrasonic sounds. Best example, elephants. Elephants can able to hear this infrasonic sounds. Even the frequency less than 20 hertz also elephants. So, but when these infrasonic sounds will produce, generally before natural disasters like tsunamis, earthquakes, these type of natural disasters, before these natural disasters, this type of infrasonic sounds will generate. So we are unable to hear, but some animals can able to hear these sounds. That is the reason they can understand before this type of natural disaster something is going to happen very strange, so that they will run randomly. They don't know what to do, but they know something is going to happen strange, so that they will run. So in some movies also we can see this type of scenes. Okay. So next, if you come for second type, sonic sounds. These sounds are called as audible sounds. Means human audible range. 20 hertz to 20 kilohertz. 20 hertz to 20 kilohertz. This is the human audible range. When we are able to hear some sound, when we are able to hear some sound, that compulsory the frequency should be 20 hertz to 20 kilohertz. Then only we are able to hear. And if it is more than 20 kilohertz or less than 20 hertz, we are unable to hear. Audible range or sonic sounds. If you come for a third type, ultrasonic sounds. The sounds, those are having frequency more than 20 kilohertz or 20,000 hertz. Both are same. 20 kilohertz or 20,000 hertz, both are same. So that frequency sounds are called as ultrasonic sounds. Okay, I'm repeating the point. Sound waves, those are having frequency more than 20 kilohertz or 20,000 hertz. These frequency sounds are called as ultrasonic sounds, very high frequency sounds. Okay, in our ultrasonic testing, we are going to select or we are going to use these ultrasonic sounds. The reason why, sir, why only ultra, why not infra, why not sonic? See, in our ultrasonic testing, main advantage is finding internal defects along with the depth. That is main advantage because RT, PET, MPT, these methods cannot provide depth. Cannot provide depthness. The only method you can get the depth, UT. So, for example, this wall is there. I want to test this wall. Thickness or its internal any defect is there. At what depth the defect? At which location the defect? Or else metal. This metal. Customer provided this. I want to know whether this material having any defect inside or not. If it is there, at which location the defect? In that location, at what depth the defect is? I want to find. So UT can give that information. So if you want to find internal defects of the mediums or objects, so your sound have to enter through the material types. So we need high penetrating intensity, high penetration ability. The sound wave which is having high frequency, then it can even penetrate through high denser material, like what? Like metals. Like metals. So that is the reason in our ultrasonic test, we are going to find internal defects of the materials by sending high frequency sounds through the materials. Then a sound which is having high frequency can even penetrate through materials, means high denser materials. That is the reason in UT we selected ultrasonic sound. to test the materials. So obviously, ultrasonic sound is not going to damage the materials. So that it is an NDT process, non-destructive testing. And compare with the remaining methods also. Compare with the remaining PT, MPT, RT also. UT is the safest method. So example, general example also we can take. Ultrasound testing, we can even use on the pregnant ladies. The pregnant ladies are there in a very sensitive condition, but we are using ultrasound testing on the pregnant ladies. You can imagine how much safe. But RT not a safe. We are not going to prefer this type of radiographic testing on the pregnant ladies. Okay, so UT is the safest method for the technician and also for a material. It is not going to damage the material. Remember, guys, whatever the doubts you will get when I am explaining, you can raise your doubts first. Don't follow blindly. My okay. Also, if you have any questions or any doubts, you can raise your doubts. No problem. Because UT is a very important concept. Okay. So next, okay, we just discussed two topics only. What is sound? Types of sound. And reason for selection of ultrasonic sound is high frequency and penetration. Next, velocity of sound. Guys, I have a question. Can we generate sound anywhere, guys? Can we generate sound anywhere? Yes or no? Can we generate sound anywhere? Am I
If we
audible?
can, we can generate sound.
Yeah, I'm asking question. Is it possible to generate sound anywhere? Yes or no? Where being calm? Your voice is breaking, Rahmat. Any answer? So, guys, if the question is if can we generate sound anywhere means answer is no. Because we cannot generate sound in the vacuum where there is no medium. We cannot generate sound. Example space. No sound in the space because no medium in the space. So no sound. So sound is a medium, not matter whatever it is. Might be air, water, glass, this wall, this table, even in the human body. So if you want to generate sound, compulsory there should be a medium. Whatever the medium it will be, but it needs medium. Where there is no medium, there is no sound. But if the question is, can we generate sound anywhere on the earth? Then what will be your answer? Yes. Earth having atmosphere. The earth atmosphere is there, medium is there, air is there. So on the earth you can generate sound anywhere else, but not in the vacuum. Remember this. Okay. Next, sound having velocity. Am I correct?
Yes.
Sound having velocity. So guys, what is the difference between sound and velocity? Both are same or different? Sound and velocity, both are same or different? What is the difference, Shahid, between sound and velocity? Second is good. Second answer is example. But a small point I want to tell you. Speed, distance per time, velocity, displacement per time. Simple. Okay. But even if you want to go very deep, Velocity having direction, speed not having direction. Velocity is a vector quantity. Speed is a scalar quantity. But sometimes generally we use this word speed of sound, speed of light. But exact word is velocity of light, exact word if you want. Because light and sound will travel in a proper direction. Even I am generating sound right now. Until it touches any another medium, in which direction I am sending this sound, same direction it will travel. Suddenly, if any object is there, when it is touches the object, it will get reflected. But until the object, it will go in a proper direction. So, best word if you want to use velocity of sound. Because sound having a direction, when it is generating means it will travel in a certain direction. So that sound having velocity, it is having a proper direction. So it is a vector quantity. Next, guys, sound velocity is limited or unlimited? Velocity of sound, limited or unlimited? Very good. It is limited. Limited velocity means why this mobile phones directly we can speak with each other from America, Australia, China, Japan. Unlimited it will travel. So sound having velocity, it is limited. Sound velocity same or different in all mediums. Velocity of sound same or different in all mediums.
Different in all mediums, sir.
Why it is different, son?
Because of the density differences.
Exactly. So sound velocity is not same in all mediums due to change in the density. Very good. Exact answer. So sound velocity and density relationship, for example, air, water is steel. So solid, liquid, gases. In which medium sound velocity more?
Air,
Air. Okay.
yes, sir.
What is sound velocity in air? Why? Like, can you tell me why in air it is more sound velocity?
Because the density of air is less compared to the water and the hard material.
So less density, more velocity.
Yes, sir. In sound, less density, more sound.
So in less denser medium, sound can travel fast.
Yes, sir. Yes, sir.
Okay. So think logically. For example, in some movies we can see when the train is coming from so far, when it's coming or not, we will keep our ear on the railway track and we can listen to sound when it is coming vibration. Have you seen this type of things? Have you seen this type of things? Point is here, guys. Sound velocity will be there. In every medium, sound can travel with some velocity, guys. Will be common. Yeah. I'm coming to the point. But we need some explanation. Blindly, if I said that word, it will be not correct. So some explanation required, guys. Okay. So according to Sami's answer, I'm taking some explanation. I'm taking three mediums here: air, water. For solid, I take steel. Okay, so I'm taking velocities also at a time. Approximately 330 meter per second. Okay. Water, 1470 meter per second.
Will be less.
Still, 5920 meter per second. Okay. So these are the velocities. This is medium. This is velocity. This is velocity. Okay, of course, plus or minus, because sound velocity based on the density. Density of mediums will be changed depends on temperature also. Because when the temperature is more, and the air temperature and air density, water density, materials properties will change. That's why approximation values will be there. Okay, so I'm giving these standard values according to our ASME, okay? Air, water, steel, 5920, which we will use in our UT also. So why it is happening? First of all, guys, in every medium, whatever it is the air, water, steel, copper, aluminum, whatever, sound will travel by transferring energy. How it will be, for example, air. Just before we discuss it, low denser medium. So density means molecular distance is more molecular distance like this. So if you take water, there will be the density. Mass per unit volume, simple. Less area, more mass. Density is nothing but mass per unit value. So water. Next, steel, if you take, more matter in less area. Okay, so now I want to generate sound. Sound generation means very simple, generating of vibrations. For example, you see here, this is a table I have in front of me. I want to generate sound. Simply, I'm hitting the table with my hand. So generating vibration sound is traveling through the table also. So same way, when I generate the vibrations through this medium, if I generate the sound with 100% of energy, so it will hit this, it will hit this, it will hit this, it will hit this, and it will go like this. But you see here, due to the less density, what will happen? Here 100 means, will it be same 100 here, guys?
No, sir.
It will be less.
Reduced.
Correct?
Yeah.
Okay, imagine I'm taking 80, I'm taking 60, I'm taking 40, and it will stop. Okay, so if you take water here, then here if you take 100, if you take 100, then here 90 will be. Am I correct or not?
Yes, sir.
Yes.
So,
Mhm.
so if it is still, if it is 100 here, okay, here 95. Am I correct?
95.
Yeah.
Okay.
80.
So, due to that, what happens, in which medium sound can travel with more velocity?
Steel, sir.
Obviously, high
Steel,
denser
yes, sir.
mediums will travel faster, no?
Yes, sir, because
High
molecules are
denser
very close.
mediums, yes, high denser medium sound velocity will be more compared with the low denser medium. So, but not matter, only velocity is not a matter, guys. Some amount of velocity will be changed based on the elastic nature of the atoms. Modulus of velocity also will affect in this. Okay, so that velocity of sound in the mediums. Velocity of sound in the mediums will be depends upon density and modulus of velocity also, but mainly density. So if you want to make it clear, I am gonna show you a video also, guys, because we should be very clear about this concept. Because velocity only play important role in our ultrasonic testing, sound velocity. So that first I'll make you clear about this, then I'll change the topic. Oh, okay, you can see in this video, guys, clearly how sound wave is traveling steel, water, and air. See how fast sound reflecting in steel. See here, guys, how slowly it is moving because of long distance.
Yes, sir.
Are you clear with this velocity concept, density, velocity?
Yeah, very interesting.
Thank you. So, guys, next sound intensity matters. Guys, when sound traveling distance increases, intensity will
Decrease.
decrease. Because imagine we are there in the classroom and I'm teaching from the board. you sit in front of me one by one. The person who is sit in front of me as a first student, he will get more. The last one will be less. Am I correct? Because when
Yes.
sound traveling distance increases, sound intensity will reduce, guys. Another
Yes.
point we have to read. Next, guys, when sound touches any interface, what will happen? Where interface means where two different mediums are contacting with each other. Where two different mediums are contacting with each other, that surface is called as interface. Interface,
Mhm.
interface. My hand is
Mhm.
also interface. Even my face is also
Mhm.
interface.
Mhm.
Wherever two different mediums are contacting with each other, that surface is called as interface. So when sound
Okay.
touches the interface, it will get reflected. Am I correct or no?
Mhm. Yes. Yes.
So presently I am generating sound. My sound touches the wall which is in front of me. When it is touches the wall, what will happen? When it is touches the wall, what will happen? It will reflect less. I have a question. Will 100% of sound reflect?
No, sir.
No. Some sound will,
We
Deviate.
degree
sound will enter through the wall also. Some sound will enter through the wall.
Enter. Yes.
That's why outsiders, presently I am alone in this room. Outside my admin department is there. Okay. So when I'm teaching in this classroom, I was locked the door. But still they can get some noise from inside of this room. Am I correct or no?
Yes.
Why? Because sound which can even transmit through this wall also. But question is, which will be more, guys? Reflection more or transmission more? Reflection more or transmission more? Guys, which will be more? Reflection and sound more or transmission sound more? Reflection will be more. Transmission will be always less. That's why outside people can understand someone speaking inside. Some noise is there inside. But he cannot understand what I am teaching here. But if the person who is inside this classroom, he can easily understand what I am just telling. Reason reflection is more compared with the transmission. Anywhere it will happen. More sound will reflect compared with the transmission. Same way, when you are sending sound through any medium, when suddenly medium change, when sound touches the different medium changes, density change. Density changes, velocity change. Velocity change, sound will reflect. So now I am generating sound here. My sound is traveling like this. Until the wall surface air is there. In air, sound velocity 330 meter per second. With 330 meter per second velocity, sound is traveling. When it is touches the wall, suddenly wall is different medium. Density changes. So sound velocity also changes. Some sound will reflect. Some sound will enter. The sound which is entered through the wall, that is called as transmitted sound. The sound which is reflecting from the wall, that is reflected. Compare with the transmission, reflection will be more. Remember these points. Because our total ultrasonic testing will run based on this transmission or reflection, receiving, based on this concept. Okay, whatever I have explained until now, you can see in this PDF. So, source ultrasonic sound. Please confirm, are you able to see my screen? Give me a response fast, guys. Thank you. Source, mechanical vibration. Sound is a mechanical vibration. It means medium to travel. We can't generate sound in the web. Types of sounds. Three types: infra, sonic, ultrasonic. In that, sonic only audible, infra and ultra not audible. Our selected sounds are ultrasonic sound, high frequency and penetration. Sound traveling distance increases, intensity decreases. We already discussed about it. Sound velocity, sound having velocity is limited. We already discussed this. Sound velocity will be different and different medium. I have already given the example, same example I have taken. So density, velocity. Here resistance also matters, guys. Resistance means opposing force. Very simple it is. Opposing force means what? For example, what I said earlier, here to here when energy is transferring, when the distance is more, resistance also more. So more resistance, less velocity. That's why here resistance also added in this concept. Okay, so the relationship between density and velocity directly proportional, velocity and resistance inversely proportional. Here already I have mentioned. Okay, so next, when sound touches any different medium, it will get reflect back. What is the different medium, sir? Like interface. What is interface? The surface at where two different mediums are contacting with each other, that is called as interface. This is the source of sound, like you can use any sound source like a speaker, anything. Which is generating sound, the 100% you can imagine. When it is touches any different medium like a wall, so the surface of wall can work like an interface, so sound will reflect back. But 80% sound is reflecting, 20% sound entering through the wall. From the 20%, 10% wall is absorbing, remaining 10% is going out. Okay, so absorption percentage, transmission percentage, reflection percentage. So some explanation, amount of sound reflection depends on the type and density of the material. I already, you see here guys, I already 80% I have mentioned here, but it is not fixed guys. You know, this wall is there, it's completely polished wall, like super plastered wall. So when the wall is like this, reflection will increase guys. So now when the wall is completely rough, reflection decreases. So same way, how much percentage of sound is reflecting, it will slightly depends upon density of material, type of surface, smoothness of surface, different. Just like if completely it is a glass room, more than 99% will reflect only. That's why outsiders unable to get any voice from inside. When if it is a glass room, so that amount of sound reflection also will be depends upon the wall surface, wall density, and wall properties also, by interface properties. Remember. Next, basic principle. Ultrasonic sound basic principle, acoustic impedance mismatch. What is this acoustic impedance mismatch? Acoustic means sound. We already discussed sound is a mechanical vibration, types of sound. Impedance means resistance. Resistance means opposing force. Opposing force. Mismatch means difference. Simple concept it is. In ultrasonic testing, you are sending sound through one medium, whatever it is. Sound is going with some velocity. Suddenly different medium. Okay, medium changes. So what's happening there? Density changes. Due to change in the density, the resistance of sound also will change. When resistance changes, velocity changes. Due to change in the velocity, sound is getting reflected. This reflective sound will received by our devices. Due to receiving of this reflected sound only, in ultrasonic testing, we will get result. So that's why I said in UT, this transmission, reflection, receiving, these words will play a very important role. Okay. Next, in ultrasonic testing, we are going to use a machine. That machine name is ultrasonic flaw detector machine. Ultrasonic flaw detector machine. Where flaw means defect, cavity, void, discontinuity, different ways. Okay. By using ultrasonic testing, we will detect the flaws or defects inside the material. So that's why it is called as ultrasonic flaw detector, UFD. So UFD mission or ultrasonic testing procedure, it needs three parts. One is monitor of machine, means UFD machine, and important device called as a probe. Probe is a device which will send and receive, means transmits and receives the ultrasonic sound. So how, sir, how it is possible, how it will generate sound, how it will receive the sound, what will be inside the probe, what is the mechanism inside, we will discuss that, because there's a separate topic, probe topic is there. It's complete 2 hours class is there on the probe. Okay, so in the topic I will explain. So until the topic, you just consider that probe is a device which can send and receive the ultrasonics. That's it. So this probe machine, these two will be connected with the help of a cable bus connected. Okay, so like this, the probe machine having two connectors here you can see. So one is T, means transmitter. Another one is R, means transmitter, receiver. Receiver. T for transmitter, for sending signal. R for receive, means receiving the signal. Next, this is the probe, which will send and receive the ultrasonic sound through the material. Next, machine having two scales, x-axis and y-axis. X-axis will represent depth of the defect. Y-axis will represent intensity of sound probe received. Both. Okay. So next, customer will provide a material. This is the material my customer provided. So which material he provided, guys? Type of material, steel. What is the thickness he provided?
3 centimeter.
Okay, 30 mm thickness material, that to steel material, my customer provided to me. Of course, he will provide this information. Basic. Okay, so that means I want to test a steel material which is having 3 centimeter thickness by using ultrasonic testing process. Okay, so now I connected the probe, I placed the probe on the material also. But immediately your machine cannot give any result. Why? Because your machine needs some information. Because if you directly place probe on one material, how it will give result? If you just sit in front of the any doctor and all, if you ask him to give me the treatment, which treatment he will, you have to tell your problem. You have to give some basic information to the doctor. According to your problem and all, he will decide the treatment. Same way, if you directly place probe on the material, it cannot give any result. So you have to give some basic information. In that basic information, type of material is the very important. Means which type of material we are testing, guys? Steel material we are testing. So what is sound velocity in steel? 5920 meter per second. 920 meter per second. So this velocity I need to set in my machine. How to set? We have a button. Okay, we have a button called as velocity in our machine. So see here. Can you see velocity button in our machine?
No.
Okay. By using this button called as velocity, we can set the velocity of our present testing material in our machine. How much should I set, guys? How much should I set?
5,092 and 20.
920. Okay, done. I set the velocity. But still your machine cannot give any result. Why? Because if you place the probe directly on any material, your sound cannot penetrate through the workpiece. Because if you place two solid materials one on one, compulsory there will be air gap allowed. Compulsory there will be air gap allowed. So when air gap is there between the probe and test surface, sound penetration will become less. Sound cannot penetrate properly through the. When sound cannot properly penetrate through the job, how could it give the results, guys? Because if you want to get the result on the UFD machine, sound should enter through the material. It should reflect. Reflected sound should receive by your probe. Then only result. But if the air gap is there, sound is not even properly penetrating through the material. How could we see the result? So that I want to fill this air gap by using some high denser medium. But that should not be a solid. Because if you take another solid medium between probe and test surface, again air gap will come. So that the gap between the probe and the test surface, you should fill with any liquid or semi-solid medium. Any liquid or semi-solid medium you can use between the probe and the test surface. It might be water, oil, grease, gel, whatever. So that medium which we will use between the probe and the test surface is called as couplant. COUPLENT, couplant. The contact medium which we will apply between the probe and the test surface is called as couplant, which will remove the air gap between the probe and test surface and also will increase the penetrating percentage of sound inside the material. Okay. Okay, we applied the coupling on the test surface. On the test surface, we applied the coupling. Now your machine is ready. Probe is also covered with some coupling. So when you apply the coupling and if you place the probe, your probe will send sound through the workpiece. So the sound which is entering through the workpiece, that is called as transmission of sound. So when sound going, okay, when sound going through the workpiece, so up to 3 centimeter steel is there. Sound velocity in steel 5920 meter per second. So up to 3 centimeter distance, sound will travel with the velocity of 5920. But after 3 centimeters, no steel. But what is there? Air is there. Air is different medium. Steel density different. Air density different. Different medium. Medium changes after 3. So wherever
Yes.
medium changes, that surface will become an interface. When sound touches the interface, what will happen?
You reflect.
It will reflect. The sound which is reflecting from the back wall of the material or back interface, it will again reflect back to the probe. The sound which is reflecting from the probe, that sound will be received by the probe. The sound which is reflecting, the reflected sound will be received by the probe and it will inform to the probe at what distance the sound is getting reflected. At what distance sound reflecting, guys? From what distance sound?
30 mm.
30 mm or 3. So when this reflected sound probe receives, so it's got informed it is 3 centimeters. So this information your probe will send to the machine with the help of receiver cable. When machine received this information, then immediately machine will display an echo at the depth of 3 centimeters on your monitor. See here. Where it is displaying the echo? At what depth it is displaying?
3 centimeters.
3 centimeters. Okay. So sound transmitted, reflected, received. We got it. But will it stop there? Will the sound stop there? Guys?
No.
It will reflect and
So guys, now in this room, I'm generating sound. There is a wall in front of me. My sound will touch that wall. It will reflect. It will touch this wall.
sound,
Again, it
sound
will
will
reflect back.
transmit.
It will reflect back. Again, it will touch that wall. It will reflect. So that sound will do multiple reflections, not one. How many reflections it will do? It is depends upon the intensity of sound which you have generated. So, for example, 100% I have generated. It went there, it will become 80. It went here, 60, 40, 20, 10, 5, 2.5. Like this, after 6 or 7 reflections, it will become 0. Okay. So, same way, when you are sending the sound through the material, that sound also will reflect multiple times inside the material. First time, first reflection, probe receiving distance 3 centimeters. But second time also sound reflection distance how much? Second time also sound reflecting from at what depth, guys? How much depth it is reflecting? Second time also 3 plus 3. How much?
6.
6. So second time sound reflection distance will be at second time sound reflection 6. And third 9. Fourth
12.
12. So it will continuously. 3, 6, 9, 12, 15, 18, 21. It will continue. So that means what? If you place probe on one material, but multiple echoes, your machine will display that. Why it is displaying multiple echoes? Because your sound means the sound which you are sending, that is doing multiple times reflection inside the material. So for every reflection, machine is giving result. Okay. So, but in this image, all echoes are not having same height, guys. You see that? Echo height is decreasing. First echo, second echo, third echo. Why is this echo height is decreasing? Can anyone? Why echo height is decreasing?
Because of the resistance
Ah,
intensity decreases.
because depth increases, intensity will decrease, na? So first time sound traveling distance 3 centimeters, so more sound reflect. Second time distance traveling distance 6, then reflection percentage decreases. So the first echo 80 means second echo 40 only. Height. Echo height means intensity. Intensity. Height means intensity. So 80, 40, 20, 10. According to this, can we see unlimited number of echoes? Can we see the echoes unlimited or limited? Guys,
Limited.
can we see unlimited number of echoes on the screen? No.
No, sir.
Unlimited. Because limited number of echoes only. Because when intensity decreases now, when depth increases. So first echo, if it is showing 100 means
Yes.
second echo 50, then 25.
And then
Then
after
half,
some time
then
it will
half,
be
then
zero.
half, then after some time it will become
0.
0.
Zero.
Same way, my voice, I am speaking something. It is going away from me. Intensity reduced. Maximum up to 10 meters or 8 meter, 9 meter distance only it can travel. After that, no sound. It will become 0. Same way. Even when you place the probe on material also, it will do multiple reflections. But when number of reflection increases, intensity will decrease. so that echo heights also will decrease. So it is showing multiple echoes on the screen, guys. But which echo is giving the thickness of the material in all the three echoes, guys? Which echo is giving material thickness?
10 centimeter.
Which echo is giving thickness of material? The first one, am I
Three.
correct? The
3
first one.
centimeter.
So in all these echoes, which echo will give you thickness of the material or total thickness of the material? That echo is called as back wall echo. Means the echo which is reflecting from back wall of the material. It is giving back wall thickness of the workpiece. That's the reason it is called as back wall. After back wall echo, the remaining echoes are called as reflected echoes. Why reflected echoes? Because these echoes are coming due to multiple reflections of sound inside the material. That's why these are called as reflected echoes. Why these echo heights will be in decreasing order, guys?
Because intensity
of-
is decreasing
Intensity
Exactly.
decreasing
Due
and
to-
velocity
due to resistance.
Due to here, simple answer.
loss
Due to
of
loss of
intensity.
This is the first case of our UFD machine working. In this first case, 3 questions will be there. Okay, what is the first question, guys?
What is back wall echo?
What is the answer?
Total thickness of job.
Thickness of the test space.
Okay, so next, why reflected echoes will come?
Due to multiple
Multiple
reflections of sound in
reflection
job.
of the sound in job.
Why echo heights will be in decreasing order?
Due to loss of sound intensity.
That's it. Any questions in this first case, guys? You can ask me, please. I'll show you the total image at a time once. Any questions in the first case? Observe carefully the screen. Any questions, please?
No, sir.
Okay. Next, let's go to second case.
Yeah, I have a question.
Yes. Please carry on.
We have the sound. What is multiplying is by 3 because our test space is 3. We have 3, 6, 9, and so on and so off. The sound cannot fall on 3, and after 3, it cannot fall on 5 or 4 or 7.
But there is no defect in between, because you see here, in this case, I am taking the material like this, which is having thickness 3 centimeters.
Yeah.
3 centimeters. I am sending sound from this surface. It is touching here. It is reflecting back. At what distance it is reflecting?
3 centimeters.
Okay, first echo 3. Second time also it is reflecting from 3 centimeters only, na?
Yes.
In between it is not reflecting. It is reflecting from 3 only second time. So 3 plus 3 how much?
6.
So that's why second echo 6 only. Then 9.
Okay.
In case if something is there in between, then it will reflect from there. But nothing is there here, no? But you can answer for one more question also. When backward echo will come? When backward echo will come? Waiting for your answer.
When sound touches the end of the thickness of the
I
job.
need simple answer. This is the answer.
Oh, yes.
Obviously, when there is no defect, backward echo only will display, na? Sound will go
Yes.
total thickness. Sir.
Yes, a smooth surface.
Yes. So, only 2 questions, guys. What is backward echo? And when backward echo? The two questions are, what is back wall echo? You can answer like total thickness. When back wall echo will come?
It
When surface is
defects.
without
When there
defect.
is no defect. When there is no defect. Are you clear?
Yes.
Okay. Let me again take you to the second case. Now case 2 is there. In case 2, I am taking a defect in the material. I am taking a defect in the material. Okay, so can I get back wall echo now? Can I get back wall
Yes.
echo now?
No,
I am
no,
repeating
no,
the question.
no,
I am repeating the question. Can I get back wall echo now?
no.
Why we cannot get back wall echo?
Because in
Because
between
of
there is a
the
defect.
indication.
Exactly, because sound not going until back wall. No? Sound not going to
Back
back wall.
echo.
In case if your probe is here, then back wall.
Yes, back wall
But
echo.
now your sound is not going to back wall because in between the material only there is a defect. At what depth defect is there?
At
2
2
centimeter.
centimeter.
So sound is reflecting from 2 centimeters. Probe will send the same information to machine. Machine will receive this information. So machine will give echo at what depth?
4
Where,
centimeter.
where machine will give echo? First echo.
First echo 2 centimeter.
Second echo?
4
2
centimeter.
centimeter.
Yes, same concept it is, guys. So first to 2, then 4, then 6, then 8. It will continue. Echo height will reduce because depth increases. So that means what I want. So can I call this echo at 2 centimeters? Can I call it as a back wall echo?
No, sir.
No, because back wall means total thickness. But
Okay.
total thickness 3, but echo is coming at before the back. So what we can call that echo is a defect echo. Am I correct or not?
Yes, sir.
Okay, yes.
So an echo which will represent the depth of the defect is called as defect echo. That is the point. Next, for defect echo also we will get reflected echoes. Am I correct or not?
Yes.
For defect echo also we will get reflected echoes. Why? Because sound will reflect between defect and surface also. Na?
Yes.
So that defect echo also will give reflected echoes. Right? Same concept though. Reflected echo height will be in decreasing order due to loss of intensity. Same, you can see here. Second case is easy. So see here, only one question, guys. What is defect echo?
Echo will.
Yes, please. Guys, I'm audible to you. Hello.
Echo will represent depth of the defect.
Okay, depth of the defect. So, which is also have a reflected echo, which is also due to loss of intensity. So, case 3. In case 3, I'm taking a defect in the material. But which echo we will get for this case, guys? Defect echo or back wall?
Defect echo for the middle
Defect
part.
echo. Defect echo. But before taking you to this concept, guys, so sound will come out from the probe. For example, consider this is the probe. Sound beam will come like this. This is the sound beam. Okay. So in first case, when there is no defect, the total sound which your probe is sending is reflecting from back wall. Am I correct?
Yes.
So that we are getting back wall. But in second case, your workpiece having defect like this. So now the sound which your probe is sending, the total sound is reflecting from the defect. So that your machine will give defect echo because sound reflecting from the defect, it is not going to that. Second case. Am I correct? Next.
I didn't get you, sir. Can you repeat it?
In this case, the total sound which your probe is sending, which is reflecting from defect only, is it going to backward? Is
No.
any sound going to backward?
If there is a defect,
Yeah, of course, it is a defect. This is
no.
defect. So
No.
here defect is there. Due to this defect, your sound is not going to backward. So that is reflecting from defect only. Due to that, defect
Yes.
echo will be given by your machine. But in the third case, this is the defect. And your probe is sending sound like this. Is this total sound is hitting the defect? Guys, is this total sound is reflecting, touching the defect?
No, sir.
No. So only some amount of sound, some percentage of sound is touching the defect. Remaining sound is going to
Backward.
Back wall.
backward. So touching the defect, at the same time it is going to backward. So due to this, sound will reflect from two places. Some amount of sound will reflect from the defect. Some amount of sound will reflect from the back wall also. So at a time, in this case, your probe will receive two reflections. One is from, another one is from back wall.
Defects.
In this case, your machine will display two echoes at a time. What are the two echoes? What are the two echoes?
Back wall and defect.
Back wall echo and the defect echo. Which echo will be displayed first?
The
Defect
defect.
echo.
Defect echo will be first. After defect echo,
Back wall echo.
back wall echo. This is the result. This is the result. Okay, so where back wall echo is coming?
To the thickness,
3 centimeter. Where defect echo?
2 centimeter.
2
But
centimeters.
for back wall echo, reflected echo also will come now. Where reflected echo for back wall?
4 centimeter.
Back
4
wall reflection.
centimeters.
Back wall reflection 6.
6, 9,
9. Okay.
12.
Next. Defected is coming at 2. Where reflected echo will come?
4,
And third one?
6,
6.
6.
But here you see already 6. Back wall reflection is there now. Am I correct or no? Back wall 3, reflection 6 and 9. Defect 2, reflection echo 4, but third one should be come at 6. So that means what? At same location 6, 2 echoes have to come. One is back wall reflection, another one is
Another one,
defect
defected.
reflection. But UMT machine cannot display 2 echoes in the same place. No. One location, one echo. It cannot display 2 echoes. But how to solve this type of issue? But according to reflections, it have to show 2 echoes. But how it will be solved means, when your probe is sending sound, consider your probe is sending 100%. In that 100%, 60% back wall is taking, 30% defect is taking. Consider remaining is loss, 10%. Remaining is 10% loss. So if back wall at 3 centimeter, because of traveling distance of 3 centimeters, 60% of intensity means distance double, then intensity will become
30%.
Half. Correct. Then 15, then some. Same way, defect 30. Then next echo height,
15.
even if any echo is there exceeds, what will be the height of that echo?
7.5.
So that means what? At the depth of 6, at the depth of 6 centimeters, machine should display 2 echoes, guys. One is backward reflection, another one is defect reflection. But backward reflection height 30, defect reflection height 7 point. In these two, which echo height will be more? Backward reflection or defect reflection?
Backward echo.
Backward echo reflection. Then obviously the 30% echo is there means less than that echo in the same place means it will be overlapped by the bigger echo. Am I correct? In the same place, 30% of echo is there. In the same place, 7.5 echo, how could you see? It will be overlapped. No? So that then the same place, if 2 echoes have to display, our machine will display the only echo which is having more height. That is the point. Are you clear? Okay. So now there is 2 questions, guys. Okay, I'm repeating the questions again. In the 3 cases, these are 3 main cases. What is backward echo?
The echo from the thickness of the job.
Total thickness. When backward echo?
The echo from the defected. From
when
the
there is
defect.
no defect. I'm asking when backward echo. When there is no defect. When there is no defect. Next, when only defect echo will come.
When there is a defect.
When only defect echo will come. I need exact answer. Tell me this. Just 1 mark answer is enough. No
When
need
the
essay.
defects size is equal to the size of the job.
Yes. When the size of defect is greater than or is equal to the probe. Am I correct or not?
Yeah.
When the defect size is greater than or is equal to the probe, then only defect echo. The sound cannot go to that. When defect and backward both will come. When the defect and backward both. When defect and backward both echoes will come.
Will be that at the end of the job.
Again, you are trying to explain for length. See, if the defect size is smaller than the probe is, both the echoes will come out. Am I correct? Generally, your probe having diameter, it will be mentioned on the probe. See here, probe diameter or crystal diameter will be mentioned on the probe. I'll show you once probe. We mentioned it like what is the diameter, guys? What is the diameter of this crystal? 10 centimeter. Millimeters. 10 mm. Okay, so that means your probe will send the sound wave which is having 10 mm. So if the defect is smaller than that beam, obviously some sound will touch the defect, remaining will go to backward. So both you can get. When the defect is smaller than the probe, then you can get both the defect as well as backward. Okay, so next, which echo will be first, guys? Defect echo first or backward echo?
Defect echo.
Can we get defect echo after backward echo?
No, sir.
Why? Why don't we get defect echo after backward?
Sir, if we can get the defect before the backward, so it means we know that at the end there is defect. But We need to check inside material. Huh? It will
No,
be
no,
always less than.
you're trying to explain for very simple question. I'm asking just for yes or no. So my question is, can we get defect echo after the back wall? Is there any possibility is there or not? That is my question.
No,
No,
no.
sir, no possible.
Yes. Why? Because back wall echo means what? First of all, tell me.
It will
Total
catch
thickness.
the
Total
total
thickness.
thickness.
Always defect will be before the total thickness only, na?
Yes, sir.
Because it's less than the total thickness.
Yes. Your material thickness 3 centimeters. Defect at least 2.9. How it will be 3.5? Defect material only 3, na?
Mhm.
Material only 3 centimeters. How defect will be
Yes.
3.5? So no chances. So defect echo always will be present before the back wall. So after back wall, which echoes we will get?
The defected.
Reflected echoes only. So always your required area will be before the back wall. Am I correct or not? Back wall and before back wall is your required area. Am I correct? Okay. So that means what? Here, the third case, if you take, in this third case, always your required area will be back wall and before back wall, before 3 centimeters area only your required area. Because you need total thickness, and if there is any defect inside the material, you need to know that. If defect is there, obviously echo will come before this back wall only, na? After back wall, we cannot get any defect echoes. So that after the back wall, this is all the area, no need to consider this because reflected echoes will be from before after the back wall. Always your required area will be back wall and before back wall only your required area for the material testing. Any questions in these three cases, guys? Case 1, case 2, case 3. Case 1 when there is no defective. Case 2 when the defect is bigger than the probe. Case 3 when the defect is smaller than. Any doubts in these three cases? You can ask me, please. Any doubts?
No, it's clear.
Thank you. So next case 4 is there. It will be depends on the echo heights. You know, echo height of the echo will be depends upon the intensity. When you are placing the probe on any material, sound will go inside the material. If defect is there or backfall is there, sound will reflect back. How much percentage of sound or how much intensity of sound your probe will receive? Based on that, echo will be displayed on the screen. If more intensity probe received, more echo. Less intensity probe received, less echo. Simple. But this received intensity will be depends upon the two factors. First one, size. Second one, depth. Size of the defective, depth of the defect. These two will play important role in the echo heights. Okay, so how it will be? For example, let me take you to the screen.